this extraordinary artifact to the world stage, raising a single question at the heart of it all. What is the Buga sphere, and who or what sent it?
Something extraordinary fell from the sky over Colombia, a perfectly smooth metallic sphere with 9 smaller spheres locked inside, defying everything we know about natural objects on Earth. What if this isn't just space debris, but a carefully engineered artifact hiding secrets that challenge our understanding of science and technology? Imagine an artificial intelligence so advanced, it predicted the sphere's impossible internal design before any human scanning was complete. Then imagine NASA's quantum computing confirming those predictions with a precision that shakes the foundations of physics. What could this mean for humanity's place in the cosmos? And is this sphere really alive in ways we never anticipated? The mysterious Buga sphere found. In March 2025, something astonishing landed near Buga, Colombia, a perfectly smooth metallic sphere, unlike anything scientists had seen before.
What is the Buga sphere, and who or what sent it?
Unlike typical meteorites with jagged edges or visible seams, this sphere was seamless, polished, and remarkably uniform, sparking immediate curiosity. It appeared to glide with purpose before striking high-voltage power lines and falling to the ground, a trajectory that suggested it wasn't just random space debris. When researchers examined it closely, they discovered 9 smaller spheres locked within 3 concentric metal shells, intensifying the mystery. The sphere's surface was covered with unfamiliar symbols that defied classification. Scientists struggled to interpret these markings, finding no connection to any human language or known symbolic system. X-ray scans unveiled internal structures, unlike any Earth-made objects, with materials arranged in complex, layered patterns that hinted at advanced engineering. The combination of its flawless construction and inscrutable markings set off alarms in scientific communities worldwide. What immediately stood out was the precision of the sphere's internal arrangement. The 9 microspheres weren't scattered randomly, but positioned with eerie mathematical accuracy. Conventional explanations, like natural formation or terrestrial manufacturing, couldn't account for the object's features. This wasn't a puzzle that could be solved by traditional methods alone. It demanded new tools and fresh perspectives. The initial bafflement deepened as tests showed the materials inside the sphere were composed of elements and alloys that shouldn't coexist according to current metallurgical knowledge. The object's nickel-to-iron ratios and isotopic fingerprints did not match any known asteroid or terrestrial source. Researchers realized they were dealing with something that challenged not only their understanding of space objects, but also the limits of material science itself. Laboratories equipped with standard imaging techniques reached their limits. Every scan and analysis revealed anomalies that defied existing catalogs and databases. Scientists began to suspect the sphere might not be a natural remnant, but rather a manufactured artifact, crafted with precision at levels far beyond current human technology. This assumption raised profound questions about the sphere's origin and purpose. Yet, despite all these clues, the sphere remained silent. No signals, no radiation, no obvious signs of activity beyond its physical form. Its secrets stayed locked away behind layers of metal and mystery. The world awaited a breakthrough that could finally decode its nature, something powerful enough to unravel the complex patterns etched both on its surface and deep within. That breakthrough would come from an unexpected source, an artificial intelligence designed not just to calculate, but to reason, to dig through mountains of data and see what humans could not. But to understand the role of this AI, we first need to explore the extraordinary scanning methods that began unveiling the sphere's hidden complexity. Advanced scanning reveals oddities. To peer inside the Buga sphere without damaging it, scientists turn to muon tomography, a cutting-edge imaging technique that uses high-energy subatomic particles to map dense materials. This method, often used to scan Egyptian pyramids or detect concealed nuclear materials, allowed researchers to visualize every cavity, chamber, and microsphere within the sphere's layered shells without any invasive procedures. The scans revealed an intricate internal structure far more complex than any conventional object.
Past 3 months, something wild has been happening across the planet.
Next came isotopic fingerprinting, a technique that examines the ratio of isotopes, variants of elements with different neutron counts, to determine where materials originated. Earth metals, meteorites, and lunar samples all have distinct isotopic signatures. When applied to the Buga sphere's alloys, the results were perplexing. The ratios did not match anything from our solar system or known terrestrial sources. This pointed strongly toward an extraterrestrial origin, but also suggested manufacturing methods unknown to current science. One of the most startling revelations came from magnetic hysteresis mapping. This technology examines whether materials can store information through magnetic patterns. Much like hard drives encode data, researchers discovered layered magnetic signatures locked in place within the Buga sphere's shells, suggesting the possibility that the object wasn't just structural, it was a storage device. The magnetic fields appeared deliberate and stable, raising the chilling prospect that these layers might contain a message or data preserved for unknown lengths of time. The precision of the 9 microspheres inside was particularly telling. Their arrangement was not haphazard or naturally chaotic, but followed precise geometric patterns. This was functional design, not accidental clustering. The spatial relationships between these inner cores resembled highly complex systems, hinting at both purpose and intelligence behind their construction. Could these microspheres be sensors, data nodes, or components of a mechanism? These discoveries left scientists grappling with contradictions. The Buga sphere's materials and structures defied earthly physics, yet physical laws were obeyed with extraordinary precision. It was unlike any artifact or natural object catalogued in the history of astronomy or metallurgy. Each layer, each magnetic trace, and each microsphere added new layers to an unfolding enigma demanding more advanced analysis tools. That's where Grok 4, an AI designed to reason at levels far beyond typical software, entered the picture. Its ability to process vast amounts of data and find patterns invisible to humans would become the key to interpreting these baffling scans. But even Grok 4 wouldn't just crunch data. It would analyze and predict aspects of the Buga sphere that left human experts stunned. Unraveling the Buga sphere's mysteries required a synthesis of techniques, from muon tomography to magnetic mapping, to assemble a comprehensive picture. Yet, only when combined with Grok 4's predictive reasoning did the sphere begin to reveal a deeper, almost sci-fi level of complexity. Grok 4's breakthrough analysis. Grok 4, launched in July 2025 by Elon Musk's XAI group, isn't your standard chatbot. With an enormous 128,000 token context window, this AI can instantly absorb entire research papers and search the web in real time.
Hey Grok.
Hello there. How can I help you today?
We're going to do a little test. Can you repeat after me? 1.
It doesn't simply answer questions. It approaches problems as a detective would, breaking them into logical components and uncovering subtle patterns buried in noise. When tasked with the Buga sphere, Grok 4 went beyond what any human or conventional AI could imagine. The AI's geometric analysis identified uncanny correspondences between the sphere's internal structure and theoretical megastructures from astrophysics. It spotted segments reminiscent of Dyson spheres, massive shell-like constructs theorized to encircle stars and capture their energy. The Buga sphere's 3 concentric shells mirrored scaled-down versions of these designs, suggesting not just advanced engineering, but possibly a message encoded through universal physics. Further, Grok 4 noticed the arrangement of the 9 microspheres echoed the molecular structure of fullerenes, carbon molecules shaped like soccer balls used in nanotechnology. More strikingly, the spacing between these microspheres matched exact orbital resonance ratios, the mathematical relationships that govern stable planetary orbits. To Grok 4, this was no coincidence. It was a structural language spanning atomic to cosmic scales. The AI compared the sphere to millions of known natural formations, engineering blueprints, and astrophysical phenomena. The matches kept appearing with astonishing frequency, not random echoes, but consistent design principles. Grok 4's predictions extended beyond geometry. suggesting material compositions and quantum signatures thought impossible to exist simultaneously. These were hypotheses made well before human scientists completed detailed scans. NASA's quantum computing facilities then took Grok 4's predictions further by simulating the physical and quantum behaviors of the proposed configurations. These simulations confirmed the AI's theories with astounding precision, validating the sphere's exotic alloys and internal organization. This level of alignment between AI prediction and quantum simulation was unprecedented. Grok 4 demonstrated not just data processing power, but genuine reasoning by connecting dots from nanoscale materials to planetary mechanics. Its insights suggested the Buga sphere was a deliberately engineered artifact, potentially holding information encoded in its materials and magnetic fields. This revelation transformed the sphere from an unexplained anomaly into a complex puzzle with clear patterns and intent. This breakthrough raised profound questions. If Grok 4 and NASA's quantum AI could decode such advanced patterns, what other secrets might exist hidden in plain sight? And perhaps most unsettling, was the Buga sphere truly inert? Or could it be considered alive in an information processing sense we have yet to understand? The intersection of Grok 4's reasoning and NASA's quantum computing marked a turning point in how humanity might uncover and interpret non-human artifacts. Yet much remained unknown, with the most critical discoveries still waiting beneath the surface. While the technology unraveled part of the puzzle, the implications of this finding stretched far beyond the lab, opening a door to questions about who made the Buga sphere and why it arrived on Earth when it did. The sphere's mysterious origin would soon confront the full power of NASA's quantum AI in ways that defy ordinary explanation. NASA's quantum validation. NASA's Quantum Artificial Intelligence Lab operates on the frontier of computational power, tackling problems beyond the reach of classical supercomputers. These quantum systems simulate millions of scenarios simultaneously, exploring exotic materials and complex physical phenomena. When Grok 4 made its predictions about the Buga sphere's internal structure and materials, NASA's quantum processors stepped in to test those claims under real-world physics and quantum mechanics constraints.
Quantum computers promise to solve problems that are impossible for traditional computers.
The lab's most advanced quantum memory devices, storing information in laser-cooled atoms, allow it to test scenarios at unprecedented speeds and scales. This means it can instantly simulate every metallurgical combination, every structural configuration, and even exotic manufacturing processes that might create such an object. Applied to the Buga sphere, these quantum simulations successfully validated the AI's proposed material ratios, isotopic signatures, and geometric alignments with near-perfect accuracy. Quantum simulations also tackled the question of whether the sphere's concentric shells could form naturally during atmospheric entry. Millions of trajectories and physical reactions were calculated in parallel, ruling out random formation theories with statistical certainty. The microsphere's precise positioning was no longer just plausible design. It became a near-impossible coincidence if left unexplained by engineering. Beyond materials and form, NASA's quantum team simulated the magnetic hysteresis patterns locked in the sphere's layers. Their models tested if these magnetic signatures could store information comparable to hard drives or advanced data capsules. The results suggested that not only does the sphere store encoded data, but the patterns themselves follow non-random, highly structured sequences. This hinted that the object was more than a static artifact. It was a message waiting to be decrypted. The combined power of Grok 4 and NASA's quantum systems represents a monumental leap in investigative capability. AI reasoning provides detailed hypotheses, and quantum simulation offers physical testing beyond any laboratory's prior reach. For the first time, two of humanity's most advanced technologies converge to examine an object that defies conventional origins or purpose. This extraordinary partnership turned the Buga sphere from an enigma into a scientifically testable subject with consistent, confirmable datasets. NASA's quantum AI not only endorsed Grok 4's structural predictions, but took them further, revealing new layers of complexity and potential functionality. The fusion of these technologies isn't just about solving mysteries, it's about rewriting what's possible in discovery. Yet, with every answer NASA's quantum lab unlocks, new questions emerge. What is the purpose of this quantum-level information storage? Could the Bugosphere be a sensor, a beacon, or a time capsule? And most tantalizingly, why focus so much computational power on a tangible object found in rural Colombia? Those questions echo far beyond science, striking at the heart of humanity's place in the universe. As quantum simulations validated AI's cryptic deciphering, the stakes rose, not just for science, but for technology, philosophy, and culture. If the Bugosphere is engineered, it forces a reckoning with what advanced civilizations might leave behind and how humanity might respond. A single object, once dismissed as mere curiosity, now carries the weight of a potential technological revolution and a doorway into profound cosmic mysteries. Implications of an engineered object. If the Bugosphere truly emerges as a manufactured artifact, the implications ripple across multiple domains. First is the technological disruption. The alloys and materials comprising the sphere show properties beyond any known Earth metallurgy: absence of impurities, seamless bonding, and resilience to extreme conditions. Reverse engineering these could unlock new industries, from aerospace to energy storage, revolutionizing manufacturing as we know it. The sphere's construction suggests a level of precision and design far superior to human capabilities. This challenges assumptions about when and how advanced materials can be produced, implying either lost ancient knowledge or contact with far more advanced civilizations. The material's ability to store complex magnetic information adds another layer, hinting at quantum-level data storage and processing that could redefine computing. Scientifically, verifying the Bugosphere as engineered disrupts long-standing narratives about extraterrestrial visitation and artifact discovery. It suggests that such objects have been infiltrating or orbiting Earth, unnoticed until our technology caught up to decode them. This forces a reconsideration of archaeological findings, ancient texts, and cultural myths that reference objects falling from the sky, perhaps not just metaphorically, but literally. The discovery also provokes profound philosophical questions about human primacy and discovery.
The writing on the Bugosphere. She goes through each symbol and explains each one in some detail.
If an artificial intelligence and quantum simulation, tools built by humanity, are the first to decode non-human intelligence, it reshapes the role of human understanding. We are no longer lone explorers, but collaborators with the very technologies we created, unlocking secrets beyond direct perception. Beyond technology and philosophy, the Bugosphere raises existential issues. If this object is a message or a beacon, what does it communicate? An invitation to learn, a warning to heed, or a record of knowledge from a distant intelligence? The presence of 9 microspheres, possibly acting as separate data cores or sensors, suggests complexity and purpose beyond simple debris. Moreover, the timing and location of the sphere's arrival spark questions about intent. Why Colombia? Why now? Could this be a test or a call for readiness as humanity steps into new epochs of quantum computing and AI reasoning? These scenarios imply advanced civilizations anticipating our technological milestones, waiting for tools like Grok 4 and NASA's quantum processors before revealing themselves. If validated fully, this discovery won't remain isolated. It expands the search for similar artifacts, possibly buried or orbiting, that quantum AI could help identify. This could open a new chapter of systematic cosmic archaeology, guided by artificial intelligence and quantum insight. The Bugosphere represents not only a scientific breakthrough, but a cultural watershed, the moment humanity confronts the tangible reality of engineered extraterrestrial technology. We now stand at a crossroads between revelation and response, with the future shaped by how we interpret and engage with this unprecedented discovery. Just as the quantum validation transformed understanding, what we choose to do next could define humanity's place in the universe for generations to come. The future of discovery. The collision of quantum computing and artificial intelligence isn't just a breakthrough, it's a transformative paradigm for how humanity searches for the unknown. The tools used to decode the Buga sphere symbolize a leap from passive observation to active, intelligent exploration. Instead of stumbling upon anomalies by chance, these combined technologies enable targeted hunts for objects that defy explanation, scanning satellite imagery, sensor data, and cosmic signals for hidden patterns. Quantum AI's capacity to process vast datasets and simulate complex scenarios at speeds classical computers cannot match opens doors to far-reaching possibilities. It can analyze decades of sensor records for signatures similar to the Buga sphere, mapping probable landing zones or
Now known as the Buga sphere, a mysterious flying sphere recovered in the town of Buga, Colombia.
orbital trajectories of other exotic artifacts. This approach shifts the search from reactive to proactive, building a systematic catalogue of anomalies with a level of precision never imagined before. Such a capability promises to revolutionize fields like astrophysics, planetary science, and even archaeology, revealing traces of non-human engineering that may have evaded detection for centuries. What was once relegated to speculation about UFOs or unexplained phenomena may soon become rigorous science supported by quantum simulations and AI reasoning. This fusion of technology expands not just our knowledge, but the very framework of exploration. The implications stretch beyond science alone. They touch cultural and philosophical domains. Discovering more artifacts like the Buga sphere raises questions about humanity's place in a universe potentially crowded with other intelligences. It challenges existing worldviews and invites global dialogues on technology, heritage, and the ethics of contact or interpretation. Moreover, the fusion of AI and quantum computing can streamline collaboration across institutions and nations. By sharing datasets and algorithms, researchers everywhere can speed discovery and prevent isolated pockets of knowledge. This could lead to an era of collective intelligence where quantum AI becomes an essential partner in decoding cosmic mysteries. As NASA and allied agencies refine these tools, we may soon witness a new age of intelligent exploration, where artificial intelligence leads in identifying anomalies and proposing hypotheses. The role of human intuition and creativity will evolve but remain vital. Guiding AI with questions and curiosity machines can't generate alone. The Buga sphere itself stands as a testament to this new frontier, a tangible object holding secrets unlocked only by the combined might of AI and quantum simulation. Its discovery urges us to prepare for more objects that might be waiting silently, coded messages or blueprints for technologies we cannot yet fathom. Ultimately, the future of discovery lies at the intersection of advanced computation and human inquiry. As quantum AI deciphers the cosmos's riddles, humanity takes a step closer to understanding whether the universe is a solitary domain or a vibrant network of intelligent life in many forms. The Buga sphere's decoding marks a turning point, revealing how quantum AI can unlock mysteries hidden in plain sight. This is just the beginning of a new era in exploration, where intelligence meets technology to reshape our cosmic story. If you're fascinated by the future of discovery, like this video and subscribe for more deep dives into the unknown.